Today we're starting a new chapter, so we're so excited, as you can tell from my Bitmoji there. We're going to start rate of change and slope. When we say rate of change, we're talking about slope, where we're talking about change in y in my numerator and change in x in my denominator. So if I'm looking at slope, we say rise over run. So what that means in my numerator, if I'm going up, then I'm going to have a positive value. For example, if I start and I count up 3, I'd have a positive 3. If I'm starting at a point and I go down, then my numerator would be negative. Same thing with my run. Same sort of idea. If I'm going to the right, my value is going to be positive. If I'm going to the left, my value is going to be negative. And then, of course, as always, you simplify your fraction. Now, the formula we use for slope, and slope is noted as m. So m is equal to y2 minus y1 over x2 minus x1. Now here's an example for you. So if I had this, 2, 3 was one point and 4, 7 was my other point. It doesn't matter which one you use as x1 and y1 versus x2 and y2. I just like to label it to get started. So that way you're being consistent to making sure that you're subtracting what you need to subtract. We have 4 different types of slopes. So if we start at the top left in purple, if our line goes bottom left to upper right, that's a positive slope. If we continue on looking at the top right, and we right's graph, we have top left to bottom right. That's a negative slope. And a lot of times in multiple choice questions, you can eliminate some answers simply by knowing whether the slope is positive or negative. Now, if we look at bottom left there, our blue line, that's a vertical line. So this is a vertical line, as we know, and that has actually an undefined slope. Now we have the little phrase VUX there. VUX kind of helps us remember things, VUX HOI. The V in VUX means it's a vertical line. The U means it's an undefined slope. And the X means as we start to write equations for lines, it's going to be X is equal to a number. X is equal to 7 or X is equal to negative 2. That's the equation for the line. Now, if we look at our last example, the red line, that is a horizontal line. And again, let's figure out what HOI stands for. Same sort of idea. That's a horizontal line. That's what the H stands for. It's a zero slope. So we're looking at the O as an O, but really it's a zero. That just helps us remember it's a zero slope. And again, when we start writing equations of line, it's going to y equals a number. So for instance, y equals 2 or y equals negative 7. Now we're ready to find some slopes. The directions say find the slope of each line that passes through the given points. So we have m is equal to y2 minus y1 over x2 minus x1. That's our formula for slope. So let's look at number 1. I'm actually going to label this x1 and y1 and x2 and y2. You don't have to do this, but in the beginning a lot of times it's helpful. So I have slope as m, and then I have y2 minus y1, which is 4 minus 2. And then I have x2 minus x1, which is 3 minus a negative 2. So that's going to be 4 minus 2 is 2. And this becomes actually 3 plus 2, right? Minus negatives plus. So I have 2/5. So that's a positive slope. So if I were to graph that, it would look something like this, bottom left to upper right. Let's look at our next example, and I'll label that as well, x1, y1. And then we have x2, y2. So let's find the slope. So I have m is equal to negative 3 minus 1, and then I have 1 minus a negative 2. So negative 3 minus 1 is negative 4, and then this, remember again, is 1 plus 2, so that gives me a positive 3. So my slope here is negative 4 over 3. Now let's go to the last one, number 3. So again, I have x1 and y1, and then I have x2 and y2. So let's find the slope. So I have m is equal to 4 minus a negative 1, and then I have 0 minus 0, which gives me 4 plus 1 over 0, which is 5 over 0. Now remember, I can't have a 0 in my denominator and any number in math. That value is actually undefined. So this would give me an undefined slope, and if you remember from your VUX HOI, that's actually a vertical line. Now we're ready to find the slope of a graph. So I have 2 points. So I think it's always easier if you start with the point to the left. So when I'm counting, I'm going to start the point to left. Remember, slope is rise over run. So in this case, I'm going to count up to, I have 1, 2, and because I'm going up, that's a positive 2. And then I'm going to the right, and remember, right is positive 1. So in this case, my slope is equal to 2, which makes sense because I have bottom left and upper right, so I have a positive slope. Let's find the slope of this given line, the purple line. So again, I have my 2 points. I'm going to start with the point to the left, and remember, it's rise over run. This time, as I start with my points left, I go down 1, 2, 3. So my slope is going to equal negative 3. And I happen to go to the right one, and to the right one is positive. So my slope of that line is negative 3, which again makes sense. I start top left and go bottom right. Now our next directions say determine whether the function is linear. So now remember, the word linear means line. And in order for something to be a line, the rate of change has to be constant. And remember, the rate of change is your slope. That's the same thing as slope. So I'm going to take a couple points here. So I have 12, negative 4, and 9, 1. So I'm going to use my slope formula. So I get negative 4 minus 1, and I have 12 minus 9, which gives me negative 5 over positive 3. So that's the slope. I'm going to keep trying something. It has to be a consistent slope for something to be a line. So I'm going to try the next two. So I have the slope is equal to 1 minus 6 over 9 minus 6, which gives me negative 5 over 3, which matches the first. So far I'm okay. Looks like it might be a line. Let's look at the last pairing. And I have slope is equal to 6 minus 11 and 6 minus 3, which again gives me negative 5 over 3. So yes, this is a linear function because it has a constant rate of change. And in summary, what that means is when we're looking at our table, each of those ordered pairs are part of the line. So we were trying to figure out if each of those 4 points were on the same line. And because we found that the slope is the same, then it is true they are all on the same line since their rate of change is consistent. Okay, let's look at our last example. It says find the value of y so that the line passing through the points 1, 4 and negative 5y has a slope of 2/3. So I have to use my slope formula. This is a little bit more advanced. I have m is equal to, remember, y2 minus y1 over x2 minus x1. So I'm going to label what I have. This is x1 and this is y1 and this is x2 and this is y2. And in this case, we're not trying to find the slope. They're giving us a slope. They're asking us to find a different, the value for y. So let's substitute what I know. I know the slope is 2/3. And I get y2, which is the y value, the unknown, minus 4. And then I have negative 5 as my x2 minus 1. So I can clean it up a little bit. I'm going to come down here. So I have 2/3 is equal to y minus 4 over negative 6. Now what I'm going to do is I'm going to cross multiply. I have a fraction on either side. So I'm going to go right here. So I have 2 times negative 6 is equal to, and I'll work on the other side there. So I have 3. Remember to put in parentheses y minus 4. So that's my original setup. So let me simplify that a little bit. I get negative 12 is equal to 3y minus 12. And I add 12 to both sides. And I have 0 is equal to 3y. Divide both sides by 3. And in this case, 0 is equal to y. Now remember, you don't have to panic because you get 0. 0 is a number, so that's an acceptable answer.